And we will need those calculators. If you guys will make sure that your calculators are in radian mode. That's a lie. We need degree mode. We're going to do things in degrees. So go ahead and change your calculators back to degree mode. So we've been working with sine and cosine so far this semester, but everything that we've been working with up till now has been right triangles. And what it turns out is there are actually some relationships involving the angle of sine, or the ratio of sine and the ratio of cosines, that works when your triangle is not a right triangle. We just have to manipulate it a little bit. And so that's what we're going to see over the next couple lessons, is this idea of law of sines and law of cosines to help us learn about triangles that are not right triangles. Okay? The law of sines says this. If we have a triangle ABC with sides little a, little b, and little c, and what I want to point out is they will do this almost exclusively from here on out, and we've seen it before, but where they label a triangle with big capital letters at each of the vertices, and ours are A, B, and C, the side across from that then, if they call this angle A, the side that is across from that, which I have highlighted kind of color-coded here, so our blue angle here across from it would be this blue side, they call that little a. So those are kind of like corresponding sides to angles. So we've got angle B up here, or vertex B, the side across from it would be then called little b, and then vertex C over here, the side across from it, little c. And what it's saying is, if we were to take the sine of the angle A and put it in the numerator of this fraction over the length of side A, it would equal the same thing if I did it with angle B. So the sine of angle B over side B, the sine of angle C over side C. This is like the format for this. You will only ever use two of them. Okay, we will compare one side, one angle, another side, another angle. We will not string together all three of them. And what happens is when we look at just two of them is it ends up looking like a proportion. And that takes us back to algebra, solving proportions, do your cross multiply thing. And if we have two of these proportions here, or two of these ratios here, we'll have 3 out of the 4 of those variables to fill in, and we'll have 1 to solve for. Okay, and we'll look at some variations of solving those. Today, just a reminder, and we've seen this set of directions before, but when it says to solve a triangle, it means to find all the missing parts. Well, anytime it says solve the triangle, they will have to have given you 3 parts. There are 6 parts to a triangle, right? 3 sides, 3 angles. They'll give you a combination of 3 parts. We have to find the missing 3 parts to get a total of 6 things in our triangle. 3 sides, 3 angles. Okay, so we'll look at a couple different combinations of what can be missing for us to use this idea of law of sines. Okay, so give you a minute to copy down this example into your notes so you have a picture to go with your work. It says solve triangle LMN, which again means that we need to find all missing parts. We should have 3 answers at the end of it. Round side lengths to the nearest tenth and angles to the nearest degree. And guys, that's going to be our directions for here on out. Sides to the nearest tenth, angles to the nearest degree always. All right, so heading forward, we're going to have 2 options eventually of how to solve these triangles, and we have to know which one to use. The key for the law of sines is, in order for it to be an option for us to use, you must know this. You must know one angle across from one side. As long as that happens, it doesn't matter what else you know, law of sines is an option. So you can see up here the side across from the angle that we know angle L, we know side L, and because we know those 2 values, we can use the law of sines to start attacking this problem. Okay? So the things we do know. We know angle L. We know side L. We know angle M. We need to figure out side M, angle N, and side N. Okay, so again, it'll always be we know three things, we need to find three things. Well, they can give us a different combination. The combination they happen to give us on this one is that we know two angles and one side. If that is the case, if we start with two angles and one side to find our missing angle here, what would we do? We've done this before. Yeah, subtract from 180, right? To find N, we're going to subtract angle L and angle M from 180. Okay, grab your calculators. 180 minus 29 minus 112. Jenna, I'll take that when you got it. Agreed? 39? Jenna? 39, all right. Okay, the sides are not as straightforward. This is not like a Pythagorean theorem thing. It is not a right triangle, so we don't get to now set up our normal like sine or cosine that we would have last 2 chapters ago or 2 sections ago to find our missing side. We have to now use this idea of law of sines. What I want you to see is we have this one right here. We will absolutely use that each time. And I would start, well, it doesn't matter. Here we have one of the angles. So if I use those two pieces of information to solve for M, what my law of sine says is that the sine of 29 over 22 equals, and on the other side we would have sine of the angle, sine of 112 over our missing side length. Okay, questions so far? Okay, this is like an algebra proportion. So remember in algebra proportions we can cross multiply to solve? Remember that rule? Okay, so if I cross multiply, I'd have m times the sine of 29 equals 22 times the sine of 112. And if I wanted to solve this for m, what would I need to do now? Divide, right? So to finish out solving this one, we would go ahead and divide by the sine of 29. Okay, so here's a get to know our calculator moment. When I type this into my calculator, I need to do one of a couple things. Type it in as a fraction. So if you have that fraction key option, you can type it in as a fraction. Or you need to make sure that you close your parentheses after the 112 before you hit divide by sine of 29, or it will think the whole thing is inside that first sign. So make sure that you either close this parentheses here or type it in as a fraction. We are currently finding a side or an angle? Side, so we will round to tenths. Okay, grab your calculators, type that in. Compare your answer with your table partner. Bella, when your table agrees on an answer, I'll take that. 42.1. Okay, any questions? All right. Guys, I know we now know this side length, but it is rounded, correct? It did not come out to exactly 42.1 on your calculators. We rounded it. Okay, so when I can avoid using a rounded number, I will, because it can impact further problems. What do I mean by that? We still need to solve for side n. I am going to continue to use what they gave me initially because that is not rounded. And so I'm going to not use the m angle and side because m's side was rounded. So I'm going to continue to use the ratio of L over L. So sine of 29 over 22. And we start this process over solving for side n. Sine of 39 over n. Okay, now this one is going to be very similar to what we just did, so I will let you take over from here. Compare your answers with your table partner. All right, Kyle, when your table agrees on an answer, I will take that from you. So 28.6. Okay. Now, this is not going to tell you what your answer should be, but it's just a little geometry theorem that I will bring back into play. In geometry, you learn that your largest side has to be across from your largest angle. Your smallest side has to be across from your smallest angle. And so I can at least make sure my answers are appropriate. I don't know that they're correct, but I know they're appropriate if my smallest angle, 29, is across from my smallest side, 22, and my biggest angle is across from my biggest side. Those are things that we would want to make sure that we are keeping an eye on. Again, it can't tell me that 28.6 is the right answer, but it's at least an appropriate answer because it was the middle of the three side lengths and the middle of the three angle measures. Okay? Any questions on that? All right. Working into some story problems. Says the angle of elevation from the top of a building to a hot air balloon is 62 degrees. And they have that drawn in this picture for us. So the picture can kind of help you draw this situation. It's got down here, it's got angle Y is marked as angle of elevation of 62 degrees. The angle of elevation to the hot air balloon from the top of a second building that is 650 feet due east. So they have these two buildings marked as a distance apart of 650 feet, is 48 degrees. So again, angle of elevation going from our horizontal up is 48 degrees. Find the distance from the hot air balloon to each building. They're asking us to find our unknown side lengths up here. Now, just so you can see, they do have this marked as a triangle XYZ, Z being up here at the top. This is Y. They're kind of small, so I'm going to make them a little bit bigger here. That would be X. And if that's the case, and again, pretty small up here, so I'll make this a little bit bigger. That means this is side Y and this is side X, little y and little x, right? So using this idea of law of sines, it tells me that the sine of the angle, like for example, sine of angle 48, over the side x would equal the sine of any other angle over its side. But if I set up, I've got angle 62 and angle 48, sine of 48 degrees over the side across from it, which is unknown, has to equal the sine of 62 degrees over the side across from it, which is also unknown. We run into a problem. I've got two unknowns in my proportion. So that's not going to work because I cannot deal with two unknowns in a proportion. We have to make some sort of an adjustment or figure something out here. What can I do from here? Elise? Yeah. I know 2 out of the 3 angles. They did not directly tell me what angle Z is, but can I figure it out? Absolutely. Okay, so let's start there. Figure out angle Z. Elizabeth, what's angle Z? That's the key. Remember, our key in law of sines is this going on. We have to have an angle across from a side. If we do not have an angle across from a side where we know both, you cannot use law of sines. And we just saw that demonstrated right here. Because I did not have an angle across from a side, it did not set up a proportion that was solvable, right? So what I would do is use what I do know. I know the sine of 70 is across from 650 feet. That gives me both numbers in that proportion, and we can do our cross multiply. I can use that sine of 70 over 650 to solve the other one that I don't have, sine of 62 over y. So I can use that same proportion for both. Okay. Again, now at this point, we know how to solve that, so I will let you guys do the cross multiply and solve. Okay, get those typed in your calculator, check with your table partner. I will get answers in just a second. But if you were on the last page not getting the answers that I was getting up there, I do want to see your calculator, see if there's something we're typing in incorrectly. IB, I'll take X when you've got it. And how about Bo, I'll take Y when you've got that. What'd you say? That is not what I thought you said. All right. Agreed? Yes? Okay. Any questions on our law of sines? These are all very similar. Again, this is your key right here. You have to have that one angle across from one side. And I keep pushing that because eventually I'm going to hand you a triangle and you're going to have options. That's what you look for. That is the key for law of sines. And eventually, once we have law of cosines, then we'll have to understand which one to use when. Angle across from a side tells me my law of sines. Okay. Sometimes we are not solving for everything. On this one, it is just solving for one missing length. It says the tree is leaning 10 degrees past vertical as shown in the figure. A wire that makes a 42-degree angle with the ground is 10 feet from the base of the tree, is attached to the top of the tree. How tall is the tree? So we got a lot of things going on, and the wording in the story is a little bit misleading. If you look at the picture, do you see what they marked as 10 degrees past vertical? 100, right? Vertical would be 90 degrees, so if we go 10 degrees past that, it would be a total of 100 degrees, and they have that marked right here. Okay. We're supposed to be finding the height of the tree, which is right here. It's kind of like what we talked about on the last problem. So I'm going to let you guys kind of take over on this one without me guiding you through the first step. Cole Svensson, what did you start with doing first? I like that. Perfect. Yeah, find angle C, right? We have to find our third angle. Again, right now we are not eligible to do law of sines. We don't have a angle across from a side. But anytime they give us two angles, we know three angles, right? So he gave us that this one is 38, which I don't know if it'll show up here. 38 degrees up here at angle C. Now I have my requirement for law of sines, an angle across from the side, and that is always, again, what we're going to be looking for to do our law of sines, and that angle across from the side always has to be one of your two proportions. We just then had to pick the correct proportion to solve for our unknown that they are asking us to solve for. Well, the unknown they're asking us to solve for is the tree, so again, going across from that would have been, we should have used angle 42 of the other two options there. And again, as I kind of am attacking this one, I see that the two angles we're working with, 38 and 42, they're not very far apart. I would expect my side lengths to not be very far apart. I've noticed a lot of us are speeding up our process here, seeing the pattern showing up over and over. Guys, that's awesome. It's not going to change. Continue to do that once you know exactly what's going to fall where. You don't have to show a lot of work on this. Okay, Olivia, when you've got a side length for that. .9. Seems appropriate to me because it is close. What were we talking in here? Feet? Feet. Questions? All right. Kind of going back to what we had before, solving the triangle. This is our one example today. Every other triangle I have shown you today, we have started with two angles and one side, right? This one, we are starting with two sides and one angle. It is possible to use law of sines on this problem because we have, again, our requirement of a side across from a known side across from a known angle, right? This happening right here, 130 degrees across from the 32. Because that is there, we know we can use law of sines as an option. But if we compare this to what we saw earlier, remember that our list of things we are trying to find notice the difference this time. We don't have two angles, so I can't do that whole subtract from 180 thing. So if I look at this chart, it kind of guides me to where I should go. Obviously, we're going to use angle B and side B in my proportion. The only other piece of information I have is side A, right? So we're going to go to finding angle A next. That's literally the only thing we can do. So let's look at the difference in what we've seen here. Sine of 130 over 32 equals the sine of, and this time our angle is unknown, sine of angle A over 24. Do my cross multiply to solve like normal. Okay. And then I would continue trying to solve for A, but look at what's going on over here at A. What do I need to do first? Divide by the 32, right? Let's get that 32 out of there. But over here it says angle A equals, not sine of angle A equals. And if you type this into your calculator, what ugliness does it give you? It's got to be some decimal, right? What is it? 0.57. Okay. That's not angle A, is it? That's the sine of angle A. How do I solve for the angle? The inverse. The inverse. Okay. Now here's what. Let's do a little get to know our calculator moment. We know we want to do the inverse of this. I don't want to round that. So what I want you to do now is we are taking the inverse of both sides. go back and do the inverse and type all of that inside your inverse sign. Okay, so that we don't have to like approximate our decimal. There's one of two ways you can do that. If you already have that typed in and it's some decimal in your calculator, when you hit your inverse sign, you can use the answer option, the second entry. Yeah. Second enter would take the answer from the line above and put it into that, or just go ahead and type that into your calculator. Should give us some angle. This side is shorter than 32. Also, I know that I can't have two obtuse angles in a triangle. Can't happen. Okay. So I know it's got to be something less than 90 degrees here. We are rounding angles to the nearest whole number, nearest degree. Cami, when your table agrees on that, I will take that answer from you. 35 degrees.
Could you just solve for side one and take the something smaller?
Yes. Just don't like retype it in. So you can insert the answer. Do you know how to do that on your calculator? Like do the second entry? You can absolutely do that. All I'm saying is don't look at that decimal and like kind of like type in like 2 or 3 of the numbers. Like actually have your calculator put it in there for you. That totally works as well. But if you round the decimal for that ugliness and then stick it in there, it's going to be now a changed number to find your number, and we don't want to do that. Okay. All right, now, guys, we're back to what we were doing before. I now know 2 out of the 3 angles. What's my third angle? 15. All I had to do is subtract from 180, right? And now continue on. We will continue using this top set of information. I can now set up the proportion to solve for side C, and this, now we are back to exactly what we saw earlier. So this last part, no different than earlier. I said always avoid using a rounded number when you can to solve for others. Sometimes we can't. Sine of 15 came from solving. I don't have an option. There is no option on this. You have to use that to solve for side C. So go ahead and use that. I would expect this to be our shortest side. And Ellie, when you've got that typed in, we'll take that from you. And we are back to sides, right? So we're going to round to 1 decimal. 10.8. Seems appropriate. Questions? Okay. So it is possible to use law of sines to solve for a missing angle. That is your other option. There's only 2 ways that solving a triangle can be handed to you. 1 angle and 2 sides, or 2 angles and 1 side. You now have an example of both. Your assignment tonight. Out of the book, you are doing 1 through 12, but you're going to skip number 11. So 1 through 10 and number 12.